Welcome back to Module 1, Mathematics. In this video, we cover angles, radians, and the properties of common shapes used throughout aircraft maintenance calculations. Angles are classified by size. An acute angle is less than 90 degrees. A right angle is exactly 90 degrees. An obtuse angle is between 90 and 180 degrees. A reflex angle is greater than 180 degrees. Two angles are complementary if they add up to 90 degrees, and supplementary if they add up to 180 degrees. A radian is a different way of measuring angles based on the radius of a circle. One radian is the angle created when the arc length equals the radius. Since the full circumference is 2 pi times the radius, a full turn is 2 pi radians, and pi radians equals 180 degrees. To convert degrees to radians, multiply by pi over 180. To convert radians to degrees, multiply by 180 over pi. Arc length is found using S equals r theta, where the angle theta must be in radians. Sector area uses a similar formula, 1/2 r squared theta, for example, if the radius is 2 meters and the angle is 1.2 radians, the arc length is 2.4 meters. These formulas are used for structural sector scans and control surface travel arcs. In any triangle, the three interior angles always sum to 180 degrees. The area is 1/2 base times height. For right-angled triangles, Pythagoras' theorem applies. The square of the longest side, called the hypotenuse, equals the sum of the squares of the other two sides. For circles, the circumference is 2 pi r, and the area is pi r squared. For example, a circle with a radius of 3 meters has a circumference of approximately 18.85 meters. These relationships apply directly to the engine bores, wheel rims, and duct cross-sections. For a rectangle, area equals length times width. For a parallelogram, area equals base times height. For a trapezium, area equals 1/2 the sum of the two parallel sides times the height. The interior angles of any quadrilateral always add up to 360 degrees. Pause the video and try this problem yourself. Using arc length equals r theta, we get 4 times 0.9, which is 3.6 meters. Using sector area, 1/2 r squared theta, we get 1/2 times 16 times 0.9, which is 7.2 square meters. Question 1. Convert 135 degrees to radians in terms of pi. The answer is B, 3 pi over 4. Question 2. A sector has radius 5 meters and angle 1.4 radians. Find the arc length. The answer is C, 7 meters. Question 3. A right triangle has sides 3 centimeters and 4 centimeters. Find the hypotenuse. The answer is A, 5 centimeters. Here is your quick reference. Pi radians equals 180 degrees. Arc length is r theta. Sector area is 1/2 r squared theta. Triangle area is 1/2 base times height. Pythagoras' theorem relates the sides of a right triangle. Circle circumference is 2 pi r, and circle area is pi r squared. That covers angles, radians, and shape properties. In the next video, we move on to graphs. See you there.